Hello and welcome everybody to our second episode about Hertz Car Audio. How are you, Ken?
I'm doing well, Luca. It's good to see you. It's good to be back. And I'm happy I get to spend today designing car audio systems.
Yeah. Today we want to show you all some of the system you can install with Hertz technology. But first, we would like to review the products in the Hertz family. Today we are going to focus on the mobile segment. Products for mobile we intend for automotive use. I've been told many times from dealers that they get confused when identify the right products for the right use. Is it maybe because Hertz counts with 150 product codes and 5 product lines?
Yeah, I think that's the case at first glance, Luca. But I find that if you look at the mobile lineup, it becomes straightforward once you get familiar with it.
I agree. So let's start then. In this slide, you can see the vertical representation of the lineup of the Hertz lineup, starting from the bottom with uno, Italian for 1. Then we add 10 at the time. Then we get to 10, which is 10 in Italian. Then cento, 100 in Italian. And then mille or mili, as you say sometimes, that is thousands in Italian. And up to here, the linearity is well clear, right? Finally, we have DSP.
Yeah, that explanation really helped me understand the relationship of uno, dieci, cento, and mille. I have to work on my Italian. On the speakers really well, but could you do this for the entire brand?
Sure, Ken. Great idea. Let me try that in a different way. Here is the lineup of speakers brands, starting at uno, Italian for 1 again, and we get great value in the most popular sizes of components and coaxials. 10 is Italian for 10, and when you step up to 10, you get excellent sensitivity and excellent off-axis response too, and all the size speakers you might need, components, coaxials, in all the needed sizes. Now, the hallmark of Cento speaker is linearity, and they can work with DAC power or with an amplifier. The most popular sizes of components and coaxials are covered. The Cento Pro models are components and coaxials intended for more demanding sound quality application with amplification. Finally, we have Mille or Mili again, Italian 4000, and the top of the Hertz speaker line. Power handling, dynamics, low distortion, and off-axis response all adds up to highest performance. Mille Legend is the reference, and the Mille Pro uses much of that technology in a more accessible price range. Now subwoofers. We have subwoofers in the Mille Legend, Mille Pro, Cento, and 10 line. We even have a sub and a 12-inch in the Uno line. We have over a dozen of different models. Our amplifiers include Mille Power, Hertz Compa Power or HCP, and D Power, where D stands and matches with 10, our entry-level amplifier.
And finally, there's the H8 DSP. It's a user-friendly DSP that can be configured to operate almost any place you need a DSP in simple systems or more advanced systems. And I think this shows Hertz is an excellent brand for specialists in building car audio systems.
And speaking of system design, what is the first thing that most consumers are looking for in your opinion, Ken?
Well, that's a great question. I made a list of what I call the 7 rules of car audio system design, and I have ranked them in order. And I think the most important thing is that the system has to be reliable. That's what people expect.
Well, I guess that is assuming, isn't it?
I think a lot of times professionals assume that. I think we take reliability for granted, but you have to select quality equipment like Hertz. Yeah. And you also need proper installation and proper setup for the system to be reliable. Now, the next thing people want is they don't want it to make any funny noises. And what I mean by that is when the engine is running or when the lights are on or you step on the brakes or maybe you turn it a little too loud.
Yeah, that is usually taken for granted too. It shouldn't be like this, in my opinion, as not every dealer is a specialist.
Yes, that is unfortunately true. So The third most important thing is that the system has to cover a wide range of notes. We cannot get high fidelity if we just use one speaker driver size. We have to have a mid-range, but we're probably going to need to have a tweeter, and we're probably going to need a woofer also.
Yeah. Some people want to get gray sound without a subwoofer, but I guess that's really hard, isn't it?
Yes, it is. We'll talk about that more in a minute. Now, rule number 4 is the one that most consumers think of first. And they want their system to play louder without distorting or blowing up. And they want it to sound better even when it's loud. And that's not just because people like loud music, although they do. It is scientifically proven that humans will hear details in the music better at a higher level.
Exactly. This is the key thing. Factory radio usually only make about 18 watts of clean power. Beyond that, distortion goes up, and they are also often not linear in the low bass.
I remember in the early days when I started in car audio, factory systems might come with only one speaker or maybe two speakers, and they were pretty small. Like in the Toyota Hilux pickup trucks, we used to replace the 4-inch speaker in the dash and put a 6.5-inch speaker in the door.
Yeah. So let's start with the examples. Here is a very basic upgrade with Hertz Uno front speakers in the 6.5-inch sides, replacing the Yon from speaker.
Now, if you want a speaker system to be louder, like if you want to get 3 decibels more output from a speaker system, you need to have more cone area, which is either larger speakers or more speakers. And you could also double your power. And that's just to get 3 decibels of increase, which is noticeable, but it isn't a huge increase. So one way to get more cone area is to install more speakers. And the rear package tray in cars was a place that we would often install more speakers.
Okay, so let's step forward. And here is a DHE upgrade with new louder speakers, front and rear. So the main concept to remember about DHE speaker is their high sensitivity. How much output we get with 1 watt of power. 3 dB more sensitivity is like having twice as much power. And I'm sorry, Ken, I've heard you don't like rear speaker very much, right?
Don't worry, Luca. That rumor is slightly exaggerated. If we want to listen at decent levels, we need more output. And the easiest way to get more output is to have more speaker area. So adding rear speakers can be thought of as essential for systems that have to be heard loud enough to hear in a moving car. In US domestic vehicles, a lot of times those rear speakers were 6x9 ovals. The oval shape would let us put a bigger speaker in the rear deck than a round speaker. A round speaker wouldn't fit. And because they were larger, they weren't just louder, they also had better bass response in the days before subwoofers. And eventually, the OEM audio systems started copying the aftermarket, and they started including 6x9s in their system from the factory. And now they've actually, in modern cars, they've taken them out of the rear deck in many cases and put them in the front doors, so they get better bass and more output from the front.
Yeah. Output is the word, and output is very important. We believe that the most important characteristic for this category of speaker is for it to play louder, but with the same amount of power. DHE speakers have higher sensitivity ratings than other speakers in their performance category. So in this system, the DHE 6.5 coaxial and the DHE 6x9 both have a sensitivity rating of 93 dBs. Most speakers in this category have sensitivity ratings 3 to 6 dB lower than that.
And that is actually a big difference because remember, to get 3 dB more from the same speaker system, you have to double the amplifier power to that speaker. So a 6 dB increase is like quadrupling the power to that speaker.
Yes, correct. And if your stock radio puts out 18 watts by 4, installing a DHE speaker that's 6 dB more efficient is like adding 72 watts by 4 amplifier.
Right. And then you could run into a power handling problem because if you added a 72 watt amplifier to OEM speakers, they might not last very long. A lot of base level, entry level OEM speakers are not designed to handle amplifier power.
Good point. But that was just an example, eh?
So this must be a great demonstration to do on a display board at your store. Switching between 2 speakers and the Hertz speaker is 6 dB louder. Wow.
Yeah, and our dealer tell us it's an easy thing to explain once you turn it on. Of course, you can add an amp.
When you add a quality external amplifier, you will get more power to move the speaker. You will also get lower distortion of the signal going to the speaker, especially during musical peaks. And you will get better linearity in low bass notes.
Now, here is another example, a DHE speaker system powered by our D-Power 4 channel amp. This amp is rated at 60 watts per channel RMS, which matches the ratings of the DHE speakers.
I am a big believer in matching the RMS rating of the amp and the RMS rating of the speaker pretty closely. There are some people that think that you can run a much, much bigger amplifier to a speaker than the RMS power rating, but I'm always concerned about heat dissipation working in that sort of situation. Now, let's talk about rule number 5. And rule number 5 says that we have to play enough bass for the listener.
And that usually means ending a sub. And for a basic upgrade, we can use the DBA200. It's a power subwoofer. And we can also use the DBA200 with the cabin upgrade. This is a very popular subwoofer system with an internal amplifier, an 8-inch subwoofer and a matching passive radiator. Now the cabin speakers have a trunk subwoofer helping them out.
We talked in episode 1 about how low bass has excursion required from the speaker. And if you use a dedicated subwoofer, it's the best way to address the excursion problem. And that way, we're not asking the cabin speakers to travel beyond their safe limits. And I've also found over the years, customers who thought they didn't get enough bass from their factory system, they would often turn up the bass tone control in the head unit to try to get more bass. And that would cause distorted sound when the system tried to deliver bass that it just wasn't capable of producing. So ideally, a system like this, the customer can turn the bass control of the radio back toward the center. And that means you'll have lower distortion on the cabin speakers, especially when the bass hits.
We can use the D-Power 1 subwoofer amp and DHE subs, such as the DBX25, a single woofer enclosure, or the DBX252, a dual woofer enclosure. Of course, this would be a more involved installation, but it would deliver more output. We've added more power and more cone area. Or you can amplify cabin DHE speakers along with the DBA200. This gives the cabin speakers more dynamic output.
Now, also, there's a high-pass crossover filter in the D-Power 4 amplifier.
Sure.
And if you use that, you can attenuate the low bass notes before the cabin speakers try to play them. So that would lower the distortion even more from the cabin speakers and improve the dynamics of the entire system. And it has some other benefits, which we'll explain more in a moment.
Here, we are using 2 amps, the D-Power 4 on the cabin speakers and the D-Power 1 on 2 subwoofers.
That is a big upgrade.
Now we have upgraded to an HCP5 channel amp. This puts cabin speakers and subwoofers into one amplifier chassis. It also gives us more flexibility on the preamp signal handling.
Well, we've come a long way, but how do we upgrade from here, Luca?
Same amp, but now we're using Cento speaker and subwoofers. The theme for Cento speaker is linearity, right? So, and handling various notes evenly for high fidelity. So Cento speakers have some great advantages. More power handling, larger tweeters that play lower note and louder, more advanced crossover filter network, better sound on and off access, more excursion and more output from the subwoofer as well.
Well, those are all very good performance upgrades.
Yeah. So now, Ken, what do you think we should do next?
Well, the next rule is rule number 6, and that says that the system should sound good. Now, personally, I think the system should sound great, but how can we do that? One way is that we could use Cento Pro front components in the system, and they're designed for amplified use. The woofer has more excursion than regular Cento, and the tweeters are a version of what is used in the Mille Pro, and those are a really big upgrade. Now, because they play lower, the tweeters play lower, we talked about this in episode 1, it improves the off-axis performance in the car door because the woofer can't play as high in the car door. Now we are at a stage where I know we could benefit from a digital signal processor.
Like with an H8 DSP?
Yeah, exactly.
So tell us what that does for us. What kind of problems the DXP fix for us?
Oh, happy to. So DSPs are used to solve three big problems in cars, in my opinion. Number one is to let the installer complete the speaker system design. They're going to use the crossovers and they're going to use the level controls for that.
Are you saying a car stereo installer is a speaker system designer?
Yes. A home speaker designer takes some different speaker drivers, puts them in a cabinet, and then tunes them so they all blend together and cover all the notes, right? Well, a car stereo installer does the same thing all the time.
That's a good point. I never thought about it that way.
So, for instance, when a crossover filter is used, you have the pass band and the stop band, but something we don't talk about as often is the transition band. And that's the center where you see that the high pass and low pass speakers are crossing over and playing the same note at the same time. Now, the crossover doesn't just keep the speaker from blowing up. It also keeps the two speakers from interfering with each other in the area where they are overlapping. And so the two speakers can only interfere with each other if they're both playing the same notes, right? Now, a good crossover will sum flat. It means that the sounds will add together so that you can't tell which speaker is playing which note. It'll be a nice, smooth response. But if you're not careful, if you select crossovers incorrectly or you implement them incorrectly, you will get a cancellation at the transition band. So when a speaker system designer is setting up a speaker system, they use the crossover filters, and then they also might use EQ, and they'll definitely use level controls to make the overall speaker system sound good. Now, the second problem that we deal with is to make up for the relative locations of all the speaker drivers. Because as we talked about in episode 1, we don't have a home speaker cabinet anymore. We took the drivers out and we put them where they fit in different locations in the car. So they are different distances from the listener, which causes a problem. And they are aimed in different directions, which makes them perform differently.
And that makes a huge difference.
It certainly does. So the third thing that we overcome is to make the OEM signals usable.
So that's the OEM integration part?
Yes. We always look at making everything perfect again by undoing we used to look at undoing everything the OEM did to make the signal perfect again. And nowadays we know there are some things that we should undo, and there are some things that we might want to use instead of undoing. But all of this is still the process of integration.
Now, is EQ really needed?
Now, that is a great question. I remember back when I was young, when dinosaurs roamed the earth, and I was in home audio and car audio at the same time. And a lot of people thought equalization was really bad. And back then, when I was young, a lot of the equalizers that were available to us would cause as many problems as they would solve. They would add hiss and they would add engine noise, for example, and that's really important on our list of rules to avoid. So let me show you why equalization is critical now that we have low noise DSP processors. So there's this thing called perceptual masking. And let's say we have two notes and they're pretty close to each other, but one of them is louder than the other. And if you look at this chart, you can see that they are both above the threshold of hearing, which means if one of them or the other of them was happening on its own, we would hear it. But because of how close they are to each other in the frequency range, they are within what we would call the masking threshold. And what that means is that the quieter note is covered up by the louder note. And even though physically our ears are detecting its presence, our brain cannot pick out that it exists. It's as if the musician never played that note. So if we equalize the louder one down, so it's closer to matching the quieter one, it does not have to be perfect. And this was something I didn't understand about equalization when I was younger. It just has to be close. If it's close, we can hear both of them. And that's the benefit of using equalization on a sound system. We will hear more of the music. By the way, this is also the reason they call it an equalizer, because we're making things closer to equal.
Well, that sounds pretty simple. But what about stereo performance?
Well, this is my last rule. And as you know, I love stereo. I think you've heard me talk about stereo before, but I think this is the rule that comes after all the others. And when we want to do stereo in a car, there are three problems we have to deal with, which I call the three problems of car stereo. And they are that one side is louder than the other, one side sounds different than the other, and the sound from one side gets there first before the sound from the other side. Now, the first of these problems is not that hard to solve because with a DSP, we have controls over every output channel for level. So we can tune them precisely so they all match. Now, the second problem is a little bit harder. We can address that by selecting a better speaker system that has better off-axis performance, because the better the off-axis performance is, the closer the left and the right performance will be. And after we select our speakers, we can use the DSP equalizer and tune the left side and the right side differently so that we get a matching response at the listening position. So the third problem is the toughest problem. And let's go back to the idea of one speaker playing a tone. And you can see the cone moving up and down. We've used this image before. Now let's add a second speaker that's playing the same signal. We would assume that that should get louder, right? We went from one speaker to two speakers. It ought to get louder. And what happens if we accidentally connect one of these speakers backwards? And we talk about how many of us have made this mistake in the past when we put two subwoofers in a box and then we get no bass because we hooked one up backwards. The two speakers are fighting each other and canceling each other out. So it didn't get any louder. And to some degree, those speakers are canceling each other. Well, what happens if we do this with a left and a right speaker? If we do this with a left and a right speaker, it ruins our stereo performance because the two speakers fight with everything that should be happening in the center of our stage. Now, what if we do two speakers and we wire them properly, but one of them is farther away than the other one? Well, we're going to get cancellations at certain frequencies now as well because of the distance. And because of how sound works, the distance will dictate which notes get canceled out. And I'll show you an example that comes from the some average distances in a car. And these red ovals show the major cancellations. The biggest one is around 200 to 250 hertz, depending on the width of the car. Now, this is a really big deal, partially because we lose a lot of output, and partially because if you look at this chart of musical instruments, you can see every single musical instrument is being affected by this problem. So we have two speakers that are different distances from the listener. What's a way to correct that? We can use delay, and we delay the near speaker so that everything arrives at the same time. And now they're in sync again. And that's really important because of the response. We don't hear it as two different arrivals. This was something I didn't understand for a long time. The farthest speaker away that you can put in a car is still not far enough for us to notice that it's farther away. The two sounds will combine at our ears and sound like a single sound. It'll just have that ragged response we showed you earlier. There won't be any echoes or anything like that. So you need processing to handle that sort of delay. The distance from the speaker is not going to make it sound like two arrivals. And here's a chart that I made that will help explain this a little bit. If you use a perfect sounding speaker on the left door and you use a perfect sounding speaker on the right door, and then you measured the response without any reflections, you would see that if one speaker is 27 inches farther away than the other speaker, and that's called a path length difference because sound travels slowly along the path. You can see the first cancellation here would be at 250 hertz, and it's a pretty big cancellation. The next cancellation would be at 750 hertz. That one's significant, but it's not as big. And then they go on from there. Now, what if we push the speaker farther out and we made it the far speaker 34 inches farther away than the near speaker? Then you can see here that first cancellation would drop down to 200 hertz. This would be a pretty wide vehicle, like maybe like a full-size pickup truck, something like that. Now, what if we pushed it all the way to 83 inches? The far speaker is 83 inches away compared to the near speaker. You can see that the first cancellation would be at 80 hertz. Now, that doesn't happen in cars because the left and the right speakers are never going to be 83 inches apart. It might happen in a boat.
But what causes this in cars?
Well, what can make the same sound arrive at two different times? There's three big causes of the same sound arriving at two different times. And the first one is left and right speakers for stereo. Now, the second one is front and rear speakers. And this is what used to drive me crazy about rear speakers, the harm they did to the frequency response if they were loud. We can correct this now with DSP by using delay. Now, the third problem is when you have a high and a low speaker on each side of the crossover, and when the crossover is overlapping, the two speakers can interfere with each other. And that could happen with a tweeter and a mid-range, or it could happen with a subwoofer and a door woofer. And this is why something as simple as the subwoofer polarity switch can make such a big difference in the sound of your system. So if an 83-inch difference causes a cancellation down at 80 Hertz, what would a 2¼ inch difference cause? That would be at around 3000 Hertz. And that is important because mids and tweeters usually are not that far apart. That can often happen. What about a 1 1/8 inch difference? Now that would be caused by that would happen at 6000 Hertz. It would cause a cancellation.
Okay,
so
then.
That's how that works.
Yeah. Now, level, crossover, path length differences, and time arrival, that's a lot. But do you manage all that with the DSP, you say?
Yeah, I do. And I used to do it multiple times a day. And once you learn a process to do it, it's really not that hard.
Okay, then. Now let me show you the Hertz H8 DSP. The Hertz H8 DSP lets you manage simple or complex systems. It has hundreds of EQ bands, time alignment delay, level controls, flexible active crossover, and lots more. The software for the H8 DSP has everything laid out very simply. If you do need to sum, the H8 DSP will automatically match the levels of the input channels to get a flat signal. It also has automated DEQ capability. This means that the OEM equalization is reversed, which can make a big difference when upgrading the speakers. And if the OEM system lacks tweeters or lacks subwoofers, for example, the EQ signal is very wrong for our performance speakers. The software for the H8 DSP has everything laid out very simply. We need crossover, delay, level, and equalization, right? And first use the setup wizard, and this will correct most OEM signals. If you're using a Toslink input or an aftermarket source, you can skip the step. When you're done, the system you've defined will be shown in this diagram in the upper left corner. The crossovers and the delay can be used to eliminate transition band cancellations. The software does the delay calculation for you. All you have to do is enter the distance to each speaker from the driver's head. All the level controls are here, and you can link them all or just the ones you choose. You can also mute any channel you choose. All these functions are very convenient when tuning a system. Finally, each of the 8 output channels has 31 bands of graphic EQ. The H8 DSP has OEM inputs, analog aux inputs, and the SPDIF Toslink. Excuse me. So it's a preamp switching controller as well. It is also an excellent audio device with a 48 kHz 24-bit DSP chipset inside and our own PC software to control it. The DRC HE gives you control of volume, subwoofer level, presets, and input source selection. Now, Ken, can you take care of showing us more about the input side?
Sure. So the H8 has 4 analog input channels, and we can configure them as front only, or we can configure them as front and rear. Now, when you configure them as front and rear, the processor will keep those channels separate, and each one will be DEQ'd back to flat. You might find situations where you use front and rear, even though they're not front and rear speakers, if you want to keep them separated. Now, you can also sum things back together. If you use them as front high and front low, then the H8 will sum the signals back together to full range and then DEQ them back to flat. Now, there's also a setting for front and sub. Now, if you set it up as front and sub, the signals will be kept separate internally. So if you have a subwoofer level control in your head unit, it will pass through just as normal. And the signals will be separately processed. So because we've got 4 channels, you could use it with an aftermarket head unit, of course, or you could use it with a 4-channel front rear system from the OEM, or you could use it with an external preamp with analog out, or you could use it with an external preamp with Toslink out.
Like a BDMI, right?
Yes.
Now, question, can you run 6 channels into it?
Well, it only has 4 inputs, but there are a couple of ways that you could work with 6 channels. And you could use an SPM, a stereo passive mixer, as an external summing device before the signal goes into the H8. Or you could use a 4-channel line output converter, such as the SLC 4.4i. Now, you can use a third-party external preamp with Toslink output right into the H8. And there are some head units now on the market that have Toslink out that will work this way as well.
Okay, all clear. Now, what can you do with the 8 outputs?
Well, there's a lot of ways to use the 8 output channels. And let me give you a couple of examples.
So that is a basic 5-channel system. DHE components in front, DHE coaxial in the rear, and DHE subwoofer all powered by an HCP5 amplifier. This is a nice audio system.
Yes, it is. Now, if we add an H8 DSP to this, we can manage the overall system response much better. We can keep the rear speakers from interfering with the front speakers using delay, and that would eliminate cancellations from that. We can keep subwoofers from interfering with the cabin midwoofers at the crossover point, and we can use advanced, steeper crossover filters to get better power handling. Now, if this customer also wants a better stereo presentation, and those are my favorite customers, then we can make the left and the right sides match in level with the DSP, and we can make them match in response with the level and the EQ. And then we can make sure that the subwoofer is in phase with the door speakers, so the subwoofer sounds like it's up front with the rest of the band.
So even with DHE, we get benefit from DSP, right?
Absolutely. Now let's upgrade it to Cento, the same basic system design with the speakers of Cento. Now we can get better off-axis performance because the tweeter can play even lower, and we have higher power handling with Cento and better mid-bass because the door woofers have more excursion. And we have better linearity overall. Now let me show you a simpler system design than this, but it's oriented toward high fidelity rather than just output. And this is a basic 3-channel system. We got Miele Pro 6.5-inch 2-way components and a Miele Pro 10-inch subwoofer. So we're using a Miele Power for amplifier. This is 150 watts to each front component set and 500 watts to the subwoofer. So this is a really good high fidelity system.
And with Miele Pro, we have a lot of the Miele Legend technology we discussed in the first episode. V-Cone, boundary-free surround, cast frame, just to name a few.
So again, we add the H8 DSP to this. Now we can manage the response at the crossover points to get better sound and more output overall. We can make left and right match to get better stereo, and we can get a smoother end-to-end response for better sound in the car, not just in the display board. Now, we will also get excellent blending of the subwoofer with the front door speakers, and we'll get better upper mid-range from the front door speakers because of the tweeters playing lower.
But we don't have any rear speakers.
Okay, we'll use the Miele Power 5 amplifier instead.
Yeah.
Then we have a couple of channels that we can use on some Miele Pro coaxials in the back, and we'll get a traditional front rear subsystem with a 5-channel amp. So the H8 DSP lets us add the rear speakers without getting any cancellations from it.
And can we do a 4-way system?
Yes, we can. Now, here is a 1-amp system with a Miele Power 5 and a Miele Pro 3-way kit.
So with the 3-way kit, we get better upper mid-range, more output, and the best off-axis performance. Why do you have the door woofers on channel 3 and 4 and the tweeters and mid-ranges on channels 1 and 2?
So passive crossover filters have to use larger components, bigger capacitors and bigger coils for lower crossover points. If we take the door woofer off the passive crossover circuit and power it directly with its own amplifier channels, We get more power to the door woofer. We don't get any side effects from the big parts from the passive crossover. And we also get direct control of the woofer level compared to the mid and tweeter speakers. This makes tuning the overall sound easier, and it lets us get more output overall. And we can manage the transition from the door woofer to the mid-range better because we have a DSP with dedicated channels and delay on each channel.
In all these systems, you've used a passive crossover somewhere. Can you show us any fully active systems?
Yes, these are my favorite. Now, here's another 1 amp system with the 5-channel amp. Channels 1 and 2 are powering the Melee Pro tweeters. Channels 3 and 4 are powering the Melee Pro door woofers, and channel 5 is powering the subwoofer. And this is a great sounding 1 amp system. It lets us manage the tweeter and woofer handoff with the DSP. And because we're using an active crossover on the tweeter instead of the passive crossover, we can steepen the slope and we can move the crossover point lower and once again improve that off-axis performance in the car.
That looks like a great sounding system, doesn't it?
Well, it is, but watch this.
Wow.
We just upgraded all the speakers to Legend. And we talked about these in the first episode. The Legend drivers in an active two-way front stage configuration with the ML280 tweeter, you can take that crossover all the way down to 1800 cycles. And that's incredible for a tweeter. And that going active lets you take full advantage of the ML280's performance.
The Miller Legends indeed are amazing drivers.
They are. And this kind of system design, it's my favorite way to use a 5-channel amp. I know a lot of people like to do front rear sub, but my favorite way to use a 5-channel amp is a fully active 3-way system with DSP.
Mm-hmm. All these systems have been 1 amp systems. I'm asking if the H8 DSP can manage system with more than 1 amp or multi-amplified systems?
That is a great question. And because it has 8 output channels, you can configure it with multiple amplifiers. Here is a fully active 4-way system with 3 amps. We have a power 4 powering the mid-ranges on one set of channels and the tweeter on another set of channels. We have another power 4 bridged to 2 more powerful channels on the 6.5-inch mid-bass. And then we have a subwoofer amp on the, we have 1 subwoofer on the Media Power 1.
Yeah. Could you use 2 subwoofers here if needed?
Yeah, you could. I just ran out of room on my system diagram, but you can absolutely use 2 subwoofers. So here is that same system layout, but with Legend drivers. And we reviewed this in depth in the first episode. This is a full reference class system. You would get amazing sound and incredible dynamics with a system like that.
Oof. We went from Uno door speakers all the way up to Miller Legend with DSP. That's a big span. It's a lot of different levels of performance, all under one brand. And I would really like to thank you for showing us all those systems, Ken. Now is your favorite part, the question and answer portion of our program. So I'm asking the attendees to use the Q&A section to interact with us. Don't use the chat because the chat goes away while the Q&A sessions remains in our files. And if we need to follow up, we can go up from there. So I'm seeing a question. Come on.
Let's see here.
Harry is saying, I'm not sure if it's us, but there is no audio. Oh,
I can hear you.
Diego is greeting from Ecuador. Luis, hey Luis, how are you? Hello again from Italy and Portland. So let's entertain us for the last few minutes of this webinar. Any curiosity on the Hertz range? I really enjoyed this webinar. It is very interesting, compact, but it gives a lot of inspiration to you. That's Ron Scott asking, Ken, what did you do before car audio? Your knowledge seems to encompass more than that.
Actually, I think I've been doing car audio since 1986 after digging trenches with an electrician contractor didn't seem like the right job for me. I did audio in church as a teenager. That's probably what you're picking up there.
I was thinking you were doing car audio in your kindergarten too. Is that the case?
They didn't let me drive the car. Well,
Alejandro, can you look a good job? Congratulations.
oh, it's very kind of you, Alejandro. Thank you. Oh, and so Henry will be able to watch the video with audio because I know that the video that Matteo posts later will have the audio track. So I'll take care of that.
Okay. Okay, Olga.
All right.
Greetings from Germany. Nope. So I think that the webinar has been very clear because there are no direct questions on the materials. What should we do?
Well,
okay. That's Travis Maddox from Australia, and this is the later guy attending our webinar, so it deserves attention.
Oh yes.
When using a passive two-way front stage and an active mid-bass driver and sub-through an H, what crossover slope do you use?
This is a great question, but it's actually a really simple question for me to answer because I basically use 24 dB Linkwitz-Riley all the time. And then I don't have to think about it. And that has to do with the phase interaction between the crossovers. I don't have to worry about testing every active crossover with different polarity because they are the same. So it is possible. I know that some people involved in very sophisticated installations will listen to every single passive crossover and decide what the perfect orientation should be. Most jobs don't have that kind of budget in them. And so my recommendation is not to try to be the crossover whisperer in most production jobs and use 24 dB Linkwitz-Riley all the time and then move on to the next step. But yeah, that's a good question.
Jorge Mario, saludos de Colombia. Ciao. Thomas Heim, greetings from Detmold, Germany. Ciao, Thomas. And Holger is wondering, any reason why would you show only 10-inch subwoofers and not 12 personal flavors?
That is also a great question. I also could not fit them into the diagram.
Yeah,
no, 12-inch subwoofers are also excellent. And I'm probably excited that I'm getting a 10-inch subwoofer enclosure for my own car soon. That's probably what is going on in my head.
So the problem, it is more to fit them into your diagram rather than in car, right?
Yes, we need more. We need bigger diagrams is what we need.
Yes, we love 12-inch subwoofer. So Ron Scott, can you provide a link to more information about the different crossover types?
Well, that one would probably take more time than we have, but I guess what I will explain is that the crossover filter types are usually named after the researcher that wrote the equations or the formulas to derive the values, which we never use, right? We just click on the menu and select them. So Butterworth and Linkwitz-Riley are the two best known, and Linkwitz-Riley came later. And the benefit of Linkwitz-Riley fourth order is that there's no phase interactions to try to have to predict with one polarity versus the other. If you select Butterworth second order, there's actually a 3 dB bump at the crossover point. So we don't want that. So Linkwitz-Riley sums to flat, much better overall performance without a lot of subsequent tweaking is, I guess, the best way for me to say it.
Okay, so Osvaldo Gonzalez from Puebla, Mexico. Excellent forum. Thanks. Ciao, ciao. Okay, Ron is thanking you. Anyone else? Any more curiosity? By the way, you can still always write at support@electromedia.it. We can we can use, and you can use this address anytime for any curiosity at any time. We'll be replying you in the shortest possible. And I think it is almost time to go for us, right, Ken? So we will be back.
I think so, but we will see you next time.
Okay, so ciao everybody, and thanks for staying with us. Greetings from Italy, and it's almost dinner time here, so it's my time to go. Probably it's your lunch almost, right?
Yeah, go get something to eat, Luca. We will see you guys later on. Thanks for
Thank
watching.
you. Thanks. Bye. Thanks everybody.